For 10.14, we're going to have a 15 kilogram bucket of water. So here's our bucket. It's 15 kilograms. It's going to have a light rope that's wrapped around a solid cylinder here. It's wrapped around there. That's going to be held in place by some kind of point there. And this thing is going to go downward and it's going to fall 10 meters. I know the scale of that is terrible. Okay. And they ask us things like what's the tension on the rope? What's the speed it gets to when it's down here? Okay. What's the time it takes here? And a really weird one, like what's the force that's exerted on the cylinder by the axle? So we got to figure out all those different things. And the only way to do that is to deal with the torques and the forces. And I'm going to start with the bucket itself. Well, the bucket is going to be, so I'm going to sum up the forces on the bucket. And those are going to be T minus mg equals negative ma. Okay. And I know a lot of those. So it's going to be T minus mg, which is going to be negative 147 newtons. 15 minus or times 9.8 equals negative 15a. And then I have to deal with the torques that go with all that stuff too. So I'm going to sum up the torques too. And I'm going to use Newton's second law for rotation, that the sum of the torques equals I alpha. The only thing that's going to put a torque on here is going to be the tension that we have going. This tension that's right here. Okay. And that's going to be T, it's going to be T times R. And that's going to be I, which is going to be the, for the mr squared and alpha. Okay. And whenever we put those together, we have an A up there. And that A is going to be really well served if we make it A over R. So we're going to replace that with TR equals 1/2 mr squared. And we'll replace this with A over R. Remember, this R is going to be this R. So one of these nicely divides out from both sides. Okay. And this other one is going to divide out from both sides. So we're going to end up with T equals 1/2 ma. Okay. Well, that actually works out pretty cool. And if we put all the numbers in it, that T equals 1/2, and this is a 12A or 6A. I think 12 kilograms is the actual mass of the bucket. We can plug it in up there. So we have 6A minus 147 newtons equals negative 15A. Bring it to the other side, you get negative 147 newtons equals negative 21A. A is going to equal 7 meters per second squared. We're going to use that information on the next screen to come up with what the rest of our values are going to be. So you'll recall from the last part that A is 7 meters per second squared, and that tension equals 6A. So that's going to be 42 newtons. That's our first part here. The next question says, well, with what speed does the bucket strike the water? That's just straight up kinematics. So for part B, to find that, I'm going to use V squared equals V naught squared plus 2A delta Y, because it's falling in this case. So V squared equals 0 squared plus 2, 7 meters per second squared. And it's going to be 10 meters. So end up with the square root of 140 meters squared per second squared. That's about 11.8 meters per second when you calculate it out. For part C, they ask the time. And for that one, I'm going to use V equals V naught plus AT. So T is just going to be 11.8 minus 0 divided by 7, 1.69 seconds. Okay. The only part of this that really is sort of challenging is part D, because it's kind of a weird thing to think about. You know, the axle on the cylinder is holding up two things. It's holding up the string. Let's say this is the cylinder. Okay. And the axle is here. Okay. The axle is holding up the cylinder. If you look at its force diagram, it is holding up. That's the force of the axle. Okay, what's pushing against it is the mg of the cylinder, and also the tension on the string, because it's pulling down, and that has to pull back up against it, right? Because it has to balance those things out. Otherwise, the actual piece is going to, otherwise the actual cylinder will just fall down. So F axle is just going to be T plus mg of the cylinder, which is just the 42 we found earlier, plus the mg of the cylinder, which is like what, 117.6 or something like that. 12 times 9.8, you get about 160 newtons when you actually finish it. Like I said, that's the only really weird part, I thought, of the whole thing. Okay. And that's it.